Okay, hello everyone. And once again, many of you have been asking me questions about class material and submitting the assignments on Google Classroom or via email. So thank you to those of you who are doing that. Okay, so last time we talked about how we can solve quadratic equations by factoring, and we'll do a quick warm-up of that. But today I want to talk about how we can solve equations by graphing. Okay, and we actually did that before already during the absolute value unit, but we'll go over how that goes once again. So do a quick warm-up, solving by factoring. Let's try the one on the right. Okay, so once again, first step is to get one side equal to 0. And because this is a negative 5a squared, what I'm going to do is I'm going to add 5a squared to both sides. So I'm going to make my right-hand side equal to 0, and then also subtract 2. Okay, so I should end up with 5a squared plus 7a and minus 6 equal to 0. Okay, and now I have to factor. Well, here I want two numbers that add to 7, multiply to negative 30. And remember, if you're factoring with a leading coefficient that's not equal to 1, we have two steps, so 5a and 5a. What are my two numbers? I think it's plus 10 minus 3. And then one more step is to simplify. Here I can divide by 5. Here I can't really do much. Equal to 0. And now we use the zero product property. So we get a equals negative 2 here, or 5a minus 3 equals 0. And I should end up with a equals 3/5. Okay, so I have a equals negative 2 or a equals 3/5. Okay, so that was solving quadratic equations by factoring, which we've done quite a bit already this semester. But now let's look at how we can solve by graphing. Okay, so recall when we did this back in the first unit of second semester, we did absolute value equations. So we have a couple steps. Okay, so first step was to, if we're given an equation, we want to graph both sides of the equal sign. Okay, so that was our first step. And then what do you want to look for once you graph it? Well, we want to look for point or points of intersection. Okay, and then our answer will be x values. So answers are the x values. Okay, so again, we don't care about the y values. All we care about is the x. Okay, so those were the steps, if you remember from before. So let's go ahead and take a look at some examples. All right, so x plus 5 squared minus 1 equals 3. So again, here's the equal sign. So first step says we're going to graph both sides of the equal sign. So let me actually kind of divide this in two. Okay, so we're going to graph the left-hand side. So y equals x plus 5 squared minus 1. And then we're going to graph the right-hand side as well. Okay, in this case, the right-hand side just y equals 3. I'll actually do that side first. Okay, so what does that look like? Y equals 3. Well, that's just going to be a horizontal line at y equals 3. So here you go. So there is my right-hand side. And then let's go ahead and graph the left as well. I'll use purple. Okay, so this is what we did in the previous unit. So this is in vertex form. Where's my vertex? My vertex is negative 5, negative 1, because I'm shifted left 5 and down 1. So let's go ahead and graph that. 3, 4, 5. Okay, and then my parabola is going to open up because there's no negative. And the leading coefficient is 1, which means I'm just going to follow my usual pattern of points. So then from this point, I'm going to go up 1, up 3, and then up 5, which is here and here. And then there is my parabola. Okay, so that's step 1. Graph both sides of the equal sign. Step 2, look for points of intersection. Okay, well, here they are. Right over here and right over here. Let me highlight those. Okay, and then the answers are the x values. Okay, so remember, we only care about what the x values are. Okay, so then for this one on the left, it looks like x equals negative 7. And then the one on the right, that looks like -3. So then my final answers will be -7 and -3. Okay, so just like before, with the absolute value equations, the steps are all the same, except now we're dealing with quadratics. Okay, so let's try a couple more just for practice. Again, I'm gonna break apart into two sides. So we have y equals 0 on this side. And let me graph that first. That's actually just gonna be my y-axis. So, or x-axis, excuse me, y equals 0. And then my right-hand side, which again I'll use a different color, is once again a quadratic, but this is in standard form. Okay, so for standard form, remember, I'm first gonna find my axis of symmetry. So x equals -b/2a. That was our formula that we used. So I have -b, so -4 over 2 times a, which is -2. So that's 4 over -4, which is -1. So that's my x value of the vertex. So vertex, x is -1. And then to find the y, I just need to plug it into my original equation. So let's see. So that's going to be -2 times 1, and then +4 plus 6. So that looks like 8. Okay, so my vertex is -1 comma 8. Let me go ahead and graph that. And in this case, again, normally I will go down 1 and then down 3. In this case, I have a -2 in front, so I'm going to go down, but I'm going to go down by 2 and 6, multiply those values by 2. So I'll go down 2 and then go down 6, which is going to be right here and here. And then there is my parabola. Okay, so there's step 1. Step 2, look for my intersection points. There we go. And then once again, my final answer, I just care about the x values. So that looks like x equals -3 and x equals +1. Okay, so there we go. And in this case, I should also mention that what we found are actually the x-intercepts of the parabola, right? Because those points happen to fall on the x-axis. So those are actually also called x-intercepts, or I think I mentioned this term before in a previous video. Those are also called zeros of the equation. Okay, so let's look at a few more just to kind of get the hang of this. Let's see, let's try one with intercept form. Okay, so once again, we have two sides, and then the right side, once again, just a number. So let's go ahead and graph that first. Y equals 6, which is going to be this line right over here. And then for the parabola intercept form, so again, starting with my x-intercepts, so that's going to be -2 and -6. So to find my axis of symmetry, if you remember, we're going to take the average of my intercept, so that's -4. And then my y value, again, I'm going to plug it in to the equation. Okay, so hopefully this is still fresh in your minds. So that looks like -2. Okay, so my vertex is going to be -4, comma, -2. -4, comma, -2 is my vertex. So let's go ahead and graph that. -4, -2. And then here I have a 1/2 in front. So then instead of going up 1, up 3, up 5, it will be all those values divided by 2. So let's go 0.5, and then 1.5, and then 2.5. Okay, I'm still not at the green line yet, so let's go ahead and keep going. Normally I'll go up 7, but I'll cut that in half, so that'll be 3.5, and I think that's gonna be right there and there. So there is my parabola. And once again, my points of intersection, and I only care about the x values. So in this case, it looks like I have x equals 0 and -8. Okay, so I'll let you guys try a couple of these as well, but I do want to talk about one on the back or on the last page as well, just to see kind of a more challenging type of problem. Okay, let's try this one right over here. So here I have y equals 2x minus 5. Okay, so this is not just a number anymore. This is actually a linear function, so that's a line. Okay, so how do we graph a line? Well, we start with the y-intercept, which is negative 5. So let's go down 5. And then we go to the slope, is 2, or 2 over 1. So then I'm going to go up 2 over 1, up 2 over 1. Or I can go down to left 1, and so on. Okay, so there is my left side. I have a line. And then the right side, again, I have a parabola. In this case, this is also in intercept form. Where are my x-intercepts? As 0, 0, and 6, 0. So then if I take the average of my intercepts, I get x equals 3. And then plugging that into our equation, I get negative 3 times negative 3, so that's positive 9. And my vertex looks like positive 9. Okay, so let's go 3 up 9. And then notice I have a negative in front, so I know my parabola is going to be going down. And it's going to be down 1, down 3, and down 5. So let's go ahead and do that. So down 1, and then here's down 3, and then 1, 2, 3, 4, 5, and 5. And let's actually do one more. Let's go down 7 as well. So let's go 1, 2, 3, 4, 5, 6, 7. There it is. And then down 7 here. Okay, so now let's go ahead and sketching our whole parabola. There it is. And there it is. Okay, so in this case, we also have 2 intersection points, but one's all the way down here and one's up there. Okay, so again, this one's a bit trickier because we still do have 2 intersection points, but they're kind of far apart. Okay, once again, we only care about the x values. So for the one on the right, that looks like x equals 5, and then x equals negative 1 for the other one, it looks like. And there we go. Okay, so that was kind of a bit of a challenge because we have a parabola and then a line, but that's not a horizontal line. That's got a slope of 2. Okay, so once again, there's really nothing was completely new for you guys. We did do some of these before, right? We did graphing quadratic equations, and we did solving by graphing during the absolute value unit. So please go ahead and make sure you take down the notes, and then go ahead and try the problems that we did not get to try in the video. And then of course, let me know if you have any questions, and I'll see you guys later.